9, let's first start by stating the goal. What is it that we're trying to accomplish with these estimation problems? Well, we're trying to estimate some population characteristic or a parameter. We want to know something about the population. But unfortunately, it's often very difficult to get these measurements from an entire population. So instead, what we're going to rely on is picking an appropriate statistic from a sample. So how do we know that something is a good estimator? Well, we call good estimators something called unbiased. So a statistic is unbiased when it does not consistently tend to underestimate or overestimate the value of the population characteristic. Now, what statistics are unbiased? Well, p hat, our sample proportion, is unbiased for p. It's an unbiased estimate for the population proportion. And x bar, the sample mean, is unbiased for the population mean, mu. So we want our statistic to be unbiased, but we also want it to have a small standard error. And that standard error is simply the standard deviation from the sampling distribution. And so the standard error for p hat that we learned in chapter 8 is given by p times 1 minus p over n, and you take the square root of that. Now, part of the problem here is we don't know p, that's what we're trying to estimate, and so you will have to estimate this standard error, and you'll do that with your p hat, and it'll be the square root of p hat 1 minus p hat divided by n. Now in chapter 10, we'll have a value for p that we're going to consider, but in chapter 9, we just have to use this estimate. So let's look at example 9.1. In a study of Supreme Courts, all criminal cases heard by the Supreme Courts of 11 states from 2000 to 2004 were examined. Of the 1,488 cases considered, 391 were decided in favor of the defendant. So the first thing we want to identify is, what is p? What is it that we're trying to estimate? And in this case, it makes sense for us to determine the true population of all cases in Supreme Courts from 2000 to 2004 decided in favor of the defendant. It's going to take me a second to write, so I'm going to pause the video. I want to pause the video as well so you can get a chance to write down that true value of p, what it is we're trying to estimate. It's important for us to know where we're going so that we know that we go the right path to get there. This is actually a rare case where we would actually know the true proportion, because this was all 1,488 cases. So our true p here would be 391 divided by 1,488, which rounds to approximately 0.263. Now let's suppose for a moment that we did not know p. So in order to estimate this, we would need to use a sample proportion. So let's say that we chose a sample size of 25, and we want to find the standard error of the sampling distribution of p hat. Now, because in this case we actually do know our true p, we're just going to use that here to calculate that standard error. But our standard error would be 0.263, 1 minus 0.263, all over 25, our sample size. And when you calculate that, you get about 0.088. Now, let's suppose for a moment that p was actually 0.4, something a little higher. What would the value of that standard error be? And so we'll still have a sample size of 25, but we'll do 0.4, 1 minus 0.4 divided by 25, and we see that that gives us a standard error of 0.098. So we notice here that our standard error, I forgot a parentheses, our standard error when we got closer to 0.5 ended up being a little bit larger. And that's something important for us to recognize, is the further away a population is from that 0.5 value, that middle value, the more accurate these estimates are going to be. And if you think about that for a moment, it should make common sense a little bit why that would happen, because when you are further away from being about 50-50, then you should be able to narrow down your estimates much better.